Hello, my name is Ian Smith, and I'm a part of Miss Redinger's biotechnology class. Now, beyond just this class, I'm also involved in a lot of other student organizations and sports. For example, I'm involved in tennis and golf, and then SCA, Interact, and even band. Now, after high school, I plan to go to a 4-year undergraduate degree to get my degree in biomedical engineering, or even bioengineering, or any other adjacent major. I've already applied to Pitt, CMU, Case Western, Penn State, a lot of really good engineering schools. And then after my undergraduate degree, I would like to pursue a master's degree, also in biomedical engineering, or if I'd like to specialize at that point into something more specific. Now after this, I would like to get my PhD as well, and then if med school takes me, I will go that way as well, if that's where I end up. So, our recent project in Miss Redinger's class was to make heart valves. So let's see my design. So, my design works a lot on gravity. And the way that it works is that we have a roll of tape, we put it inside of a glove, the glove's attached to a tube, and then the tube feeds into the actual valve, and then we have a mechanism on the bottom that'll close the valve whenever it's not being used. So, we hold it like this, and then as you can see, there's a lot of room for water to flow freely under the cup, but then when you turn it upside down, the cup falls, there's not much room, water can't really get in this way. So, how exactly does this work? Well, in this system, gravity is the replacement for the electrical systems that is telling the actual valve to open. Now, the strings themselves represent something called chordae tendineae as they close and open the valve itself. And then of course, gravity is the actual thing that causes the strings to close in this instance, and it's not just an electrical signal. Now, as I said before, the general layout, we have a piece of tape attached to the string to the chordae tendineae, or at least the replacement we have. And then it is placed inside of a glove that feeds water into the actual valve, into the actual tube in this case. And then at the very end, the cup, when it's open, will allow water to flow freely, and then when the cup is upside down or closed, the gravity from the tape will pull the chordae tendineae shut and close off the valve. Now, originally I made a design with just this marble. This marble was the only thing blocking the entire tube. Now, the problem that I ran into is that there wasn't a consistent way to stop water coming back in, and then also there was not consistent flow. So the reason for that is because to get consistent flow, or to get even a chance for water to stop, I had to make such tight tolerances that the marble was basically inside of the tube. And when I turned it upside down, water could still slip through the cracks sometimes. Now, it was not every time. But if the marble, because it was free rotating, if the marble was placed in such an orientation, maybe a drop of water or two could slip through the cracks, and then obviously you don't want any blood slipping through the cracks of a heart valve. And then the other way for flow, water would always get trapped at the bottom of the tube because the marble was blocking it, and then, if you don't have good heart valve flow, you don't really have good flow to the body, you have oxygen deprivation, all of that bad stuff. So I scratched that idea, and we came up with this idea right after. Now, let's talk a little bit more specifically about the actual parts of this. So, we've already said that the strings were representing the chordae tendineae, but the glove itself keeps water going towards the valve, so I'm going to say that is one of the chambers of our heart, maybe the atrium to a ventricle. And then the tape and the string on the cup, that's just meant to represent the actual valve itself, if you can see there. And basically all I did was I just added tape to make sure the strings could stay on there, where obviously in the actual heart, they would just be attached to the muscles themselves. Now, the cup works, as I said, as an actual block to the valve when it's closed, and it's closed by gravity, and it will stop water from going through. And then, if you'd like to consider the electrical component, you could call the force of gravity imposed by this roll of tape the electrical current, or the electrical component, because it's the thing that's actually closing the valve. And basically it's telling it to close the valve. So, what improvements would I make? Well, first of all, I think the first thing I would do is I would, ironically, make this have tighter tolerances. So, as you can see here, there's a lot of string there. There's so much string that sometimes it gets hard for the actual gravity part of this to pull it down fast and consistent. So I would have it maybe have that much room at most. And then that way, the force of gravity has an easier time getting a consistent hold. And then I'd have the strings actually go on the outside, so that way the tape is on the outside as well, so it doesn't block the water inside of the glove. Because when I was testing it, water could flow freely, but then when it got to the tape inside of the glove, it had to go around it, and it kind of blocked the flow, and then you had reduced flow to the valve itself, which obviously is not good. So what I would do is I would have strings on the outside going to the tape that's on the outside. And then again, I would have the tape have tighter tolerances, so that way it falls quicker, pulls this down quicker, and pulls it down more consistently. So yeah, there's my heart valve. I hope you enjoyed it, and I hope it's good. And thank you for watching, and thank you for doing this with us.